Hey everyone, welcome back. And today we're going to look at the origins of SOH CAH TOA. Where does SOH CAH TOA come from? And so we're going to use two things. First is the definition of sine, cos, tan. And the other thing is similar triangles. So let's do some review first of similar triangles. I created a triangle here, 5, 4, 3, a right angle triangle. And here we have, by a factor of 2, going to make it bigger. 8, 6, and 10, like that. And so these triangles are similar. And since they're similar, there's a nice property that we have here. And the property is that this 3 divided by 5 is the same as this 6 divided by 10. And let's see here, 3 over 5 equals 6 over 10, and 6 over 10 reduces to 3 over 5, which is exactly that. And the other property is here 4 over 5 is the same as 8 over 10, like that, right? We're using the similar sides like that. So 4 over 5, 8 over 10. And so 4 over 5 is 8 over 10, which does reduce to 4 over 5. So we're going to use this shortly, but this is just a quick review to remind you. So next we're going to look at the definition of sine, cos, tan. We saw that in our unit circle video. We have a circle, radius 1, and on that, a point on that circle like that, there's an x coordinate and a y coordinate at a given angle. The x component is called cos of theta. So we define cos of theta as being that x length right there at theta. And we define sine of theta to be the y component at that angle, like that. So sine of theta is the y component. And this is the definition of sine and cos. And then the definition of tan is sine over cos. So here we'd have y over x. So this is what we have for definition. We're going to apply this now with similar triangles to get a general property that we call SOH CAH TOA. So I'm going to start here with a right angle triangle from our unit circle. I'm just bringing it here. And I'm going to create a similar triangle. And the similar triangle is all the same angles. So theta, 90, and then the other angle. So they're similar triangles. And so now we're going to say, okay, sine of theta is y. By definition, we saw that. So we could also rewrite it as y over 1. But now we can start thinking about the similar triangles, saying, okay, well, this y over 1 is equal to opposite over hypotenuse, like that. And since this is equal to sine, we have sine theta equals opposite over hypotenuse. And that's where we get our SOH, S-O-H. So. Excellent. So the next one here is for cos. Cos of theta is our x value from our definition. And we can think of it as x over 1. Right? X is x over 1. And now we're going to look at the triangle and think of it as portions. X over 1 is the same as adjacent over hypotenuse. Is the same as adjacent over hypotenuse, which is equal to cos of theta. So cos of theta is adjacent over hypotenuse. And that's where we get our CAH from. C-A-H. CAH. And lastly, we have our tan of theta. Tan of theta, the definition is sine over cos. And sine, we saw it to be opposite over hypotenuse over adjacent over hypotenuse. This is sine over cos. So we're going to say, okay, opposite over hypotenuse times the reciprocal, hyp over adjacent. And the hypotenuse cancel. This here cancels out. And so what's left is opposite over adjacent, like that, which is equal to tan. So tan is equal to opposite over adjacent, T-O-A, TOA. And there we have it, SOH CAH TOA. See you in the next lesson.